students, welcome to Grow in Maths. In this video, you will get the introduction of logarithm and the derivation of sum of its formula. We have to start with one example. Okay, we have 2 to the power 5 equals to 32. Okay, now here 2 is the base and 5 is the power, and we are getting 32. Now if I want to write 5 in terms of 2 and 32, that time I have to introduce log. Okay, let's see how we can write. Here what I told, 2 is the base and 5 is the power, so we have to write it as 5 equals to log 32 to the base 2, and it is read as log 32. 5 equals to log 32 to the base 2, and again if I want to remove log, that time again the 5 will be raised at the power of 2. Here 2 to the power 5 equals to 32. Okay, now we have to take another example. We have 3 to the power minus 4. 3 to the power minus 4, and 3 to the power minus 4 equals to 1 by 81. You can calculate yourself to get 3 to the power minus 4 equals to 1 by 81. Here 3 is the base and minus 4 is the power. So if I want to write minus 4 in terms of 3 and 1 by 81, that time I have to use log, and what I should write, minus 4 equals to 1 by 81. Actually we have to write log of 1 by 81 to the base 3. Means here also we are saying that the 3 is the base. Okay, and again if I want to remove log, that time 1 by 81 equals to minus 4 will be raised at the power of 3, that is 3 to the power minus 4 equals to 1 by 81. Okay, so in general we can say that if we have a to the power x equals to m, if we have a to the power x equals to m, that time x is the power and a is the base, where from the definition we are getting that a is greater than 0, m is greater than 0, and a not equals to 1. Then x, the power, can be written as by m and a in the form log m to the base a. X equals to log m, logarithm of m to the base a. Again if I want to remove log, that time again x will be raised at the power of a. Try to see once again that at first we have a to the power x equal to m. Now if I want to write x in terms of m and a, that time we have to just use log, and we have to write it as x equal to log m to the base a, log m to the base a. And again if I want to remove log, that time just x will be raised at the power of a to the power x equal to m. Now we have to take the definition of logarithm. If a to the power x equals to m, where a greater than 0, m greater than 0, and a not equals to 1, then the power, that is x, can be written as x equals to logarithm of m to the base a, and it is read as x equals to logarithm of m to the base a. As you have already seen that 2 to the power 5 equals to 32, then the power 5 can be written as 5 equals to log 32 to the base 2. 3 to the power minus 4 equals to 1 by 3 to the power 4 equals to 1 by 81. Now the power is minus 4, base is 3, so minus 4 equals to log of 1 by 81 to the base 3. So here the power is 5 and here minus 4, but in both the cases we are getting the positive value 32 or 1 by 81. So we can say for any real x, a to the power x equal to m greater than 0, as a greater than 0. Therefore log of minus m to the base a is non-real. Why? Because for any real x we are getting m greater than 0, therefore there is no x for which we will get a to the power x where a greater than 0 less than 0. Okay, we will not get any x for which a to the power x equal to m less than 0, therefore x should be imaginary to get the value of log of minus m to the base a. Okay, so log of minus m to the base a is non-real. Now we have to see the formula, the basic formula of log. Number 1, we have log m to the base a plus log n to the base a equal to log mn to the base a. And number 2, we have log m to the base a minus log n to the base a equal to log m by n to the base a. Okay, so we have to take at first the proof of 1. To prove 1, we have to take let log m to the base a equals to x. For both of them, 1 and 2, we'll prove by this, and log n to the base a equals to y. Okay, therefore m equals to, as we have got from the definition, that a to the power x equals to m, then x equal to log m to the base a, and conversely, if we have log m to the base a equal to x, then m equal to a to the power x. So here m equal to a to the power x, n equals to a to the power y. Therefore, how to get mn? We have to take the product of these two. M into n equals to a to the power x into a to the power y, or mn equals to a to the power x into a to the power y, a to the power x plus y. So we got a to the power x plus y equals to mn. Now x plus y is the power, a is the base, so we can write the power x plus y equals to log mn to the base a. Now if we put the value of x, we have taken x equals to log m to the base a, y means log n to the base a equals to log mn to the base a. Okay, now we have to take the proof of number 2, that is we have to bring log m by n. Okay, so just from here, number 2, if we take m by n equal to a to the power x by a to the power y, implying m by n equal to a to the power x minus y. Therefore a to the power x minus y equals to m by n. Now a is the base and x minus y is the power, so we can write x minus y equals to log of m by n to the base a. So we got the right side of this formula. Now we have to put the value of x and y. X we have taken as log m to the base a, x is our log m to the base a, and y log n to the base a. So just we have to put them, log m to the base a minus log n to the base a equals to log m by n to the base a. So we got this. Number 3, log of m to the power n to the base a equals to n log m to the base a. Okay, so to prove this one, I want to take at first one example, log m square to the base a. Log m square means what? Log m into m to the base a, and as we have seen that log m to the base a plus log n to the base a equal to log mn to the base a. So conversely, for log mn to the base a, we can write log m to the base a plus log n to the base a. Okay, so here if I use the converse of this formula, that time we can write log m to the base a plus log n to the base a, m to the base a, both are m. So we are getting log m to the base a plus log m to the base a, means 2 log m to the base a, x plus x 2x. Okay, if I now write log m cube to the base a, that time log m into m to the base a, and consequently it can be written as log m to the base a plus log m to the base a plus log m to the base a, and x plus x it means 3 log m to the base a. Okay, I think you are getting log m square to the base a means log m into m, and it provides 2 log m to the base a. Log m cube to the base a, it provides 3 log m to the base a. Okay, so now if we take log m to the power n to the base a, how to prove this one? It means log m into m dot dot n times to the base a, and consequently if we use this formula, that time we'll get log m to the base a plus log m to the base a plus log m to the base a, how many times? N times. And if we add n times this, it means n log m to the base a. So we got log m to the power n to the base a. This one is very useful formula, you have to remember it. Okay, now we have to take our next formula, that is how to change the base of log. Log a to the base b into log b to the base c equal to log a to the base c. Okay, so here also like first two, we have to take let log a to the base b equals to x, log b to the base c equals to y. Now a equals to b to the power x, and here b equals to c to the power y, as c is the base, so c to the power y equals to b. Okay, these two are coming from the definition. Okay, now we are getting that right side contains only a and c, so we have to remove b. So therefore a equals to b means c to the power y. So if we put here c to the power y, it is b and to the power x. Try to get it. We have a equals to b to the power x, and b means c to the power y, so c to the power y whole to the power x, and therefore a equal to c to the power xy. Okay, so we got, or c to the power xy equals to a. Okay, that time we got 2 to the power 5 equals to 32, so we have written the power equals to log 32, the base comes here 2. So now also xy equal to log a to the base c, we got the right side. Now we have to just put the value of x and y. X we have taken log a to the base b, xy means x into y, so log a to the base b into y means log b to the base c, and we have got log a to the base c. So here we got the change of base, means if I want to change the base, that time we can use this formula, log a to the base b into log b to the base c equal to log a to the base c, or consequently the log a to the base c can be written as log a to the base b into log b to the base c. Okay, forward and backward we can use any of this. Now we have another one, that a to the power log m to the base a equals to m. Okay, this one is so simple. We have to just take let log m to the base a equals to x. Therefore from definition we are getting m equal to a to the power x. Therefore m equals to a to the power, what we have considered as x equal to log m to the base a. So now if I put the value of x here, that log m to the base a, so directly it follows the proof that a to the power log m to the base a equals to m. Okay. Okay, now some basic things I am writing in number 6, that is a to the power 0 equals to 1. So here the a is the base and 0 is the power. So, and we have to consider one more thing, that a not equals to 0. Okay, because 0 to the power 0 is undefined, so a to the power 0 equals to 1. Now the power 0 can be written as 0 equals to log 1 to the base a. So whatever be the base a, if we have log 1 to the base anything which is not equal to 0, it will provide 0. So log 1, basically log 1, the value it has 0, log 1. Again we have a to the power 1 equals to a. So 1 equals to, here the power is 1, so 1 equals to log a to the base a. Okay, so we'll use this formula in so many problems. This one is the basic formula, that a to the power 1 equals to a, and from this we are getting 1 equals to log a to the base a. Okay, and one more formula, the last one, maybe number 8, that is log a to the base b into log b to the base a equals to 1. So here to get it, we have to take let log a to the base b equal to x, implying a equals to b to the power x, as b is the base, so b to the power x provides a. Okay, now we know that b to the power x equal to a, from we can write that b equals to a to the power 1 by x. Okay, b to the power x equal to a means b equal to a to the power 1 by x. Now we have a to the power 1 by x equals to b, and 1 by x is the power, so 1 by x equals to log b to the base a. Okay, so we got 1 by x equal to log b to the base a. Now 1 equals to x into log b to the base a. If we multiply x this side, that time we are getting 1 equals to x, means what we have taken, log a to the base b into log b to the base a. So we got that our formula, that 1 equals to log a to the base b into log b to the base a. Okay.